Hello everyone, welcome to the channel. This is Fahad Mirza, and in this video we are going to have a look at the new iteration of Google's vision model, which is PaliGemma 2. Last time when I reviewed this PaliGemma around 6 or 7 months ago, this was one of the best vision models available on the market. Let's see how this PaliGemma performs on various benchmarks as we are going to install it locally, and then we will see how it works. Before that, let me give you a quick overview of this model. PaliGemma 2, as I said, is the newest iteration of Google's vision language model. Vision language models are the models through which we can read the images. This updated model combines the powerful SIGLIP image encoder with the Gemma 2 language model. That has resulted in improved performance and flexibility. There are three key features of this new model which are quite impressive. This PaliGemma 2 comes with three pre-trained models, each with 3 billion, 10 billion and 28 billion parameters that supports input resolutions of 222 4 into 222 4 and couple of others. The pre-trained models are designed for easy fine-tuning to downstream tasks, allowing practitioners to adapt the model to their specific needs. When we say that this model is more flexible than the previous one, what it means is that it has additional variants and increased flexibility that provides a better balance between quality and efficiency, so you can use it for a wide range of applications. You can use it for image captioning, or you could use it for visual question answering, and we are going to test it out for both. They were trained on a diverse data set which include WebLI, VQ2A, WIT, Open Images, and few others. It is, by the way, licensed under Gemma license that allows for redistribution, commercial use, fine tuning, and creation of model derivatives. But you can check the licensing if you have any questions for the finer details. Let's go and try to get it installed locally. Before that, let me give a huge shout out to Master Compute, who are sponsoring the VM and GPU for this video. If you are looking to rent a GPU on very affordable prices, I will drop the link to their website with a discount coupon of 50% discount. Okay, so this is my Ubuntu system, and this is my GPU card, NVIDIA RTX A6000 with 48 GB of VRAM courtesy Master Compute. Let's create a virtual environment. And now let's install all the prerequisites. Make sure to install the transformers and others from the source, because this is a very new model, only supported it in the source of transformer. And now let me launch my Jupyter notebook so that we could use this model in the browser. Okay, so now let's download the model, and you can see that we are going with this 10 billion one, and it is now being downloaded with processor and all that stuff. So let's run it, and the model is being downloaded. The size is around 5 gig for every shard. There are 4 shards, and the model is downloaded, as you can see. And then I'm quite surprised that for a 10 billion model the size is just around 20 gig. Normally this is the size for 7 billion model, so it seems it is quite a compressed model, which is quite good. Okay, so now let's do the inference. For the first one, I am just giving it the default image which they have provided through a URL. Let me also show you that image, how it looks like. So this is the image. Let's try to see what is happening here. So we are asking it to caption it in English, and this is a placeholder for image. This is the image. We are opening it, and then the processor, which is primarily using tokenizer to encode this for the model is generating the output, and I will just increase this to maybe 420 so that it will print more text, and model is going to generate the output, and then we are decoding it back. So let me run it. And there you go. So it has described the image. Let me, not this one, let me show you the image again. Now it says shots of two cats laying on a pile of brown fishing nets. That is good. The cat in the foreground is a great tabby cat with white on its chest and paws. The cat is laying on its side with its head facing the bottom right of the corner of the image. Very nice. The cat in the background is lying on its side with its head facing the top left corner of the image. The cat's body is curled up, its head is slightly turned to the right, and its front paws are tucked underneath its body. There is a real teal rope hanging from the fishing net in the top right corner of the image. There you go. You see, the rope is not that visible, but the model has identified. How good is that? Really good stuff. Okay, now let's try out with a local image. So I'm just going to replace this with a local image. And this is the image which I showed you earlier, which is just a scenery. Again, I'm asking it to describe the image. And while this runs, let me show you the VRAM consumption. So that is close to 40 gig. For a 10 billion model, I think it is not bad for 39 gig of VRAM. Okay, so let's go back. Let's wait for it. So what did it do? Okay, it's the same one. Maybe I'll just change this in English. So I have fixed the file name here, that instead of raw image, I have just put it in image, and you can see that now it has done it rightly. It says that painting of a sunset with a large yellow sun in the middle, the sky is orange, flock of birds flying on the sky on the right, that is good, tree on the left, three kangaroos in the distance, these are black silhouettes, the sun is behind them. So pretty good, I would say. Let's try to see how the OCR is. So for OCR, I am giving it this text which has some alphanumeric characters, English, some other languages, some umlauts as you can see on top of this Rapida and few others. Let's see how it goes. And I have changed the prompt to extract text from image. There you go. So looks pretty good. You can see all the characters are fine, alphanumeric characters, even these brackets are there, and it has done it very, very rightly. The only thing is, if you look here, maybe no, it looks good because this is different. This maroon and maroon. So OCR is pretty good, I would say. And then I have tried it out with this mural of David Bowie's Ziggy Stardust look, and you can see that now it has really done in bit more detail, as I also mentioned the detail in the prompt, and it has described it quite well if you read through it. You see it even went with, there is a black window with white text that reads jam. So the text reading is always quite good. I'm very impressed by the OCR, by the way. And then it has also, found the yellow pole. You see this yellow pole here. And if I show you the image, it's a very small yellow pole. Very good. Okay, so in the next example, I'm asking it what is the location of the image. And you see that it has come back, but it was unable to tell me the location of the image. I will rerun it to see if it produces anything. I have rerun it and it was unable to process the image, and it just gave me the empty answer. So it is unable to do that. So which is good because it doesn't hallucinate. If it doesn't know, it doesn't know. That is quite a good, I would say, outcome. So that's it. I believe quite a good model. Not only the size is good, very sweet spot, but also the performance is quite good. I'm especially impressed by its OCR capabilities, and this is the architecture which I shown you earlier. I will drop the link to its model card in video's description. If you like the content, please consider subscribing to the channel. If you are already subscribed, please share it among your network as it helps a lot. Thank you for watching.